Hello everyone. So I'm starting with a series where I will be discussing about different discoveries and we'll also talk about the process of discovery. My idea is to dive deep into the discoveries and look into the mind of that scientist. What did the scientist think? What was his process? How did he arrive to the conclusion that either won some Nobel Prize or the name of the scientist became an extremely important phenomenon in the history of human evolution? I want to take you to this journey where we'll find out every thought, we'll investigate the thinking process of the scientist. Let's see. Our scientist for the day is John Dalton. In an attempt to investigate the thinking process and an attempt to understand the process and the entire thought behind John Dalton's atomic theory, I have decided to convert the discussion into 4 parts. So we'll be discussing the 4 different aspects of it, and I label that as mind, M-I-N-D, where M will stand for meet. We'll meet the phenomenon. Then we'll interact, we'll try to find out more about it. Then we'll encode the numerical part of it, and then we'll try to decode the principle behind it. So we'll go with the mind and let's start. The M in mind is for meeting, and we are now today going to meet Mr. Proportion. This is what happened with John Dalton. In his laboratory, he was working with carbon and he was working with oxygen. And he found out that when the chemical reaction between carbon and oxygen takes place, carbon dioxide is formed. Not only that, he could measure the masses. And in that he found out that 12 grams of carbon will react with 32 grams of oxygen and he will get 44 grams of CO2. Some will say it is simple addition. Is it really only addition or is there something else? Let's find out. He reduced the masses to half. So 6 grams of carbon and 16 grams of oxygen produce 22 grams of carbon dioxide. Although the masses are now becoming half, so there might be some proportion about it, or there might be only addition as well, because the addition of 6 and 16 is also 22. 12 and 32 is also added to be 44. Is it an addition or is there something else? Let's find out. We know for sure that half mass of carbon is resulting in half the mass of oxygen when they are reacting together. This is our observation. We'll move on to the next slide. So we are meeting the Mr. Proportion again, and in this case we find out that 24 grams of carbon was reacting with 64 grams of oxygen and it was producing 88 grams of carbon dioxide. 18 grams of carbon reacted with 48 grams of oxygen, it produced 66 grams of carbon dioxide. Although these are only simple additions, but again there is a possibility that it may not be only addition, but it might be a proportion. 24 is to 64, 18 is to 48. Is it proportion? Is it addition? Let's find out. The masses are changing, but the proportion is remaining same. So it might be addition, it might be proportion, it might be both. We'll have to find out. In an attempt to just find out if it is addition or proportion, John Dalton came to this experiment. He tried to check it like this: 12 grams of carbon. Instead of 32 grams of oxygen, he took 40 grams of oxygen. If it was just addition, we should have got 52 grams of carbon dioxide. But it did not happen that way. He got 44 grams of carbon dioxide and the excessive oxygen, 32 grams was the reacting mass. 8 grams of oxygen is the excess mass, and that excess mass remained. This actually feels like in every meal of mine, I take 3 chapatis. So if there is a 4th one, that goes to somebody else or that has to be thrown away. 8 grams of oxygen was the excess chapati in this case. So it is surely about proportion. 12 grams will not react with 40 grams. It will only react with 32 grams and 8 grams will remain. So what are we having? 12 grams of carbon actually reacted with 32 grams of oxygen. You might have kept 40 grams of oxygen, but it did not react with 40 grams. It reacted with 32 grams. It produced 44 grams of CO2. The ratio for CO2 is definitely 3:8 because 12 is to 32 is 3:8. A bit of experimenting. Dalton said, why don't we do it the other way? Now the carbon is kept in excess. So rather than 12 grams of carbon, 24 grams of carbon. This 24 gram of carbon will react with 32 gram of oxygen, but we know 32 grams of oxygen was only reacting with 12 grams of carbon. So the 12 gram will remain. So 12 grams and 32 grams form 44 grams of CO2 and 12 grams of carbon remains unreacted as it is. So whichever is in excess will remain, and what is in the right proportion will react and get converted to CO2. That is what was happening, and Dalton came to that conclusion. Up to this point, Dalton was perfectly right, and Dalton was writing his laws. This is one of the laws of John Dalton. Law of definite proportion, or law of constant composition it is called as, where it says that if the carbon and oxygen are reacting together, or any other two elements are reacting together, then their masses will be in simple ratios of whole numbers. And the ratio will remain unchanged. You can change the masses, but the ratio or the proportion will remain constant. Was his law. But that's not the point. Dalton went on to formulate his atomic theory, and that is what I want to investigate. I am curious about a process in which the scientist has written his laws, he has proven his laws. The laws are made public. After that, somebody who proves his law will not write a theory, because theory cannot be proven. For a scientist, it is slightly inferior to write a theory. To prove a law is slightly superior. So why would a scientist start with a law, but then eventually the scientist does not end up with the law, but the scientist comes out to write only a theory? Why? Let's check that. What is the ratio? Again 24 grams, 64, again 88. It's again the same ratio is. This can be in fractions as well. The ratio will remain to be 3:8. Now the Dalton is wondering, the numerical coding, encoding is done. The ratio has been found out to be 3:8. Let's try out with some other numbers. So 3 grams of carbon, 8 grams of oxygen, 11 grams of CO2. Again the ratio is 3:8. 1.4 gram, 5 gram, 4 grams of oxygen. Again the ratio is 1.5:4 is 3:8. 0.75 2 grams, and you can just go on dividing this, and we can make smaller and smaller and smaller masses. The ratio, however, remains to be 3:8. You can reduce the masses, but the ratio does not change. Why? Let's see this. According to me, this might have happened. John Dalton was thinking about this. What can be the reason behind this? And he was having no clue about it. And on that, someday in the morning, sat with his wife on the dining table, having some breakfast and sipping coffee. And he's saying, he asked his wife, did she forget to add sugar? She said, no, the sugar is added. And then she says, oh, I poured a little bit of too much of milk. So because the milk is more, you are not finding it sweet enough. So why don't you add a little bit of sugar? You can't add the entire cube of sugar because that will make it too sweet. So add only a little bit of sugar. So John Dalton added only a bit of sugar, and the coffee tasted just right. That kind of opened eyes for Dalton. 2 spoons of sugar will make the coffee very sweet. But if it is only 1 spoon of sugar, then the coffee is not sweet enough. Half a spoon of sugar extra would add to the sweetness. It was already sweet, but was not sweet enough. So if you add a little bit of sugar more, it will become slightly more sweet. If you put only a tinge of sugar, it will still add to the sweetness. That kind of opened the eyes for Dalton. It was almost like his wife was telling him, or his entire thought process was telling him, just to wake up. Every bit of sugar is sweet. What is that sweetness got to do with this? Let's see. If you have a bowl full of sugar cubes, you can break one sugar cube and you will have tinges of sugar. So sugar cube can be broken into sugar particles. Or we can put it the other way. If sugar cube can be broken into particles of sugar, then it means that a particle of sugar had come together and many particles had formed one sugar cube. So we can say the cube can be broken into particles, or we can say that the particles of sugar came together to form a cube. Or do the sugar particles come? If a wall breaks into bricks, if you break a wall, you will get many bricks. So you might think that the bricks can be found if you break a wall. But the fact is, the wall was built using these bricks. So the sugar cube may have been formed by using the particles. This understanding led Dalton to his actual discovery. Sugar is sweet. You take 5 grams of it or you take 5 kg of it. Sugar's nature is to be sweet. You might take a lot of sugar, it will be very sweet. You take a little bit of sugar, it is slightly sweet, but it is always sweet. Carbon's nature is to react with oxygen in the ratio 3:8. You might take a little bit of carbon, it will react with a little bit of oxygen with the ratio 3:8 and will form carbon dioxide. You might take a lot of carbon, it will react with a lot of oxygen with the ratio 3:8 and will form a lot of carbon dioxide. No matter how much carbon you take, the ratio will remain same. That's carbon's property. Just like no matter how much sugar you took, everything was sweet. That was sugar's property. The property is inherited from the small particle. Just like a tiny sugar particle come together and the sugar cube is formed. So the sweetness of the sugar cube is a result of the sweetness of the small particle. Similarly, the property of reactivity with carbon is a result of the properties of reactivity with small particles of carbon element. Water is transparent. You take a little bit of water, you take a little bit of water drop, or you take a liter of water or a bucket full of water, water is transparent. Sugar is sweet. You take 1 tinge or a handful of sugar. Because every particle of the sugar is sweet. The smallest particle you can form by breaking the sugar, even that smallest particle will be sweet. Water is transparent because even the tiniest drop will be transparent. So if many drops come together, the coagulation, the collection of those droplets will also be transparent because water is transparent. Salt is salty. You take a little bit of salt, it is salty. You take many little bit tiny particles together, you make a mountain out of it. It will be salty anyway. The scaling is with the size. The scaling is with the mass. And eventually, because the mass is increased, the number of particles are more, then sweetness of sugar will be more, the saltiness of the salt will be more. But every particle will have its own saltiness. Every particle of sugar will have its own sweetness. Similarly, carbon will react with oxygen in the ratio 3:8. You can take a little bit of carbon or you can take a bucket full of carbon. Nature will not change with size. It's the nature of carbon atom. This, I think, was the sealing the deal for John Dalton. On that night, he saw that there was a thunderstorm. Before that, he had seen that when the static electricity is formed, you rub two different surfaces against each other, and there are static charges formed there. And when you bring those two particles very together, a small spark is formed. You can see that spark. You can see the spark when you take your hand very close to a screen like this. Even then, the spark can be formed. This happens because the opposite charges, when they are brought extremely close to each other, a lot of energy is transferred. And during the transfer of energy, a small fire is seen between the two particles. That is what we call a spark. This is exactly what happens when a thunderstorm takes place. Across the clouds, a lot of charge is developed, and exactly the opposite charge, the positive charge, is developed on the ground. As a result of that, the negative charges jump towards the positive charges, and when they jump, a lot of electrical arc is created. That's like fire, and the entire thunderstorm comes with that fire and an enormous electric shock, and that actually goes underground. That is how the thunderstorm is produced. That is how lightning is. In a lightning, what happens? Exactly same thing happens when you take two wires very close to each other with opposite polarities. This and this are different in scale, different in size. This is small. It will not kill you. This will surely kill you. But they are in principle absolutely the same. The moment this was realized by John Dalton, he was ready with what his theory was. The essence of a tree is present in every seed of a tree. The small seed will grow into a tree itself. In principle, they are same. Just like this one, a very small spark is basically same as the entire huge lightning. So that brings us to the ancient question. If we have 12 grams of carbon, I have 6 grams of carbon, I have 3 grams of carbon, I will keep on dividing them further. When will I stop? I will eventually stop at some point. If we keep dividing the matter into parts, what will be the end of it? No matter how small, its properties will not change, but will reach a tiniest of particle which we cannot further divide. Like every small bit of it is made up in the same way, and that smiley tiny small thing, if you reach there, you know that it is from this tiny particle that everything else is made up of. This tiny particle, in principle, the tiny particle will have the same property as the large matter. So the smallest is largest. Extremely small spark is like a huge lightning. A small atom that we know of today is also a magnet, and the entire earth is also a magnet because of the same phenomena. So we now decode the Mr. Proportion, and we say, should we ever reach a particle which is smallest possible particle, we cannot divide it further. This particle will have all the properties of that element in a nutshell. With greater quality, with greater quantity, the properties are seen to scale up in magnitude, like masses will increase, the sweetness of sugar will increase, but every particle will have its own sweetness too. But essentially the properties exist with the smallest particle as well. Dalton named this smallest particle as an atom. By this logic, by this entire process, Dalton had already arrived at the conclusion that the atoms exist. It wasn't only a theory being put up by somebody, and Dalton started to define what is an atom. And he said the atom is the smallest indivisible particle. You cannot divide it further. The atom is the origin of all the properties of matter. The properties of matter come because the properties are there with the atom. And the same properties are replicated many times. Because the atom has certain heaviness, it is very light because it is very small in size. But although it is light, it has some mass. And because atom has mass, the atoms put together form this body. And my body has mass as well. So the mass of this body is because the atom has mass. So all the properties of matter are because of the property of the atom. The atom is capable of existing in large numbers, which means the properties will be intensified or scaled up. But then what is a chemical reaction? Dalton had now left with only one question. He was left with just this: what is chemical reaction? So he said, okay, we'll take 12 grams of carbon, maybe there are n atoms of carbon, because Dalton was now seeing there are atoms. So 12 grams of carbon, so there are n atoms of carbon. 16 grams of oxygen, maybe there are n atoms of oxygen. Why, if the number of atoms are n and n in both the cases, why are the masses different? Because carbon atom's mass, one atom's mass of carbon and one atom's mass of oxygen will not be same, they will be different. So the masses of n atom will be different, masses of 16 atom will be different. These two can be added, we get 28 grams of carbon dioxide. Carbon monoxide, sorry. 12 grams of carbon, N are N atoms of carbon. 32 grams of oxygen will be 2N atoms. And they together will form 44 grams of CO2, which is N atoms of or N molecules of CO2. When Dalton reached this conclusion, he was fine with his atomic theory. He decided that atoms will combine in CO, carbon monoxide, they combine in the ratio 1:1. In CO2, they combine in the ratio 1:2. This brought Dalton to his famous theory. We'll just read through. Matter is composed of extremely small tiny particles of atoms. Particles called as atoms. Atoms cannot be further divided by chemical means. Atoms cannot be created nor can we destroy the atoms. They will only have recombinations with each other. All atoms of same element are identical in all respects. Their mass is same, their volume is same, their reactivity is same, everything is same. Atoms of different elements are dissimilar in, of course, they will have different masses, they will have different volume, they will have different reactivities. So the atoms of different masses are dissimilar. Atoms combine with each other in simple whole number ratio 1:1, 1:2, 2:3, 3:4. Simple whole number ratio, and they form what Dalton called as compound atoms, and today we call them as molecules. This is what Dalton's atomic theory was. I hope you understood this. I hope you liked it. Thank you so much.